Hello and welcome to day 2 of the BobCAM for SolidWorks 2D milling webinar. Alright, the goal of today's webinar is to gain understanding of the basic workflow of 2D milling with BobCAM V6. As you know, my name is Al DiPaolo. I'm the voice of the BobCAD After Dark video series. You can find me on Instagram at BobCAD-CAM, or you can also search hashtag BobCAD, hashtag BobCAM. All right, so what are we going to talk about today? We're going to talk about job setup, picking your stock, the different types of stock. We're going to talk about toolpath settings, the different toolpath settings you need to know about in order to machine your 2-axis parts. And then the other thing we're going to look at is reports and simulation, whether it's the setup sheets, whether it's backplotting, or other options that we have available in simulation. Now, with BobCAM, you can always expect fewer steps, better cuts, and more profit. So, while I take a moment to set up my screen, why don't you just take a moment to say where you're from and what version of the software that you're using. In our webinars here, we use the question and answer section where you can ask a question. We use that to communicate with the presenter, me. So any questions that you have, go ahead and fire away. All questions are good questions, so if you're unsure of whether you should ask it, go ahead and ask it twice. I would appreciate that, and I think everybody else will as well. All right, very good. So I want to thank Brian for showing up here today. Eric, Humberto, Jeff, Camille, Krishna, Mark, Ted, Tim, and Todd. I appreciate you guys spending some time with me here today. I know you're busy and time is money, so I do appreciate your time. So where are we gonna start off? Well, I have a sample part here. I don't have this part programmed right at this point, and really what I'm going to do is just kind of start from scratch, okay? Indiana, Eric, very good. Good to see you here today. By the way, if you guys have not joined the BobCAM for SolidWorks Facebook group, if you're on Facebook, search BobCAM for SolidWorks group. I recommend you join that group. It's a great place to learn from other like-minded individuals. So, all right, so we got our part here today. If we look at this part, a couple of different things that are going on. We have a pocket inside of a pocket. We have some, circular pockets down here at the bottom. There's a drilled hole here. These are probably tapped holes. We have another pocket with a pocket inside of it, and then in here we have kind of like this channel. So this is just simple 2D type machining, nothing really too complicated about it. Brian asked me what version of SolidWorks I'm using. Yes, I'm using 2017. I know I should have updated to 2018. It just takes a minute to install. Well, should I say more than a minute to install, and I just haven't had the downtime for it, but I'm sure I will be using 2018 soon enough. BobCAM V6 will run in 2011, I believe, or greater. So you're not going to have a problem. Yeah, exactly, Brian. No big deal. Good stuff there. All right, so what do we have? We have this part here. So the first thing, anytime you're looking at a part, there's a couple of things that you generally might look at. You might click on some of these edges here and try to get an idea of what some of the radius sizes are. If you're coming up with a process plan, you want to figure out, what tools you're going to use, how you're going to hold the part, how many operations that you might have. All those things come into consideration. General inspection of your CAD is really common. So, all right, so what do we want to do here? Well, the first thing we want to do is set up a job, okay? The job is going to be over here, okay? So here we have a job. Oh, look, I actually have some toolpath. All right, so we have this this job over here. Let's go ahead and delete. Let's get rid of this. Let's get rid of this job. So we'll delete this job. We have our part here. We're going to come into the CAM tree. We're going to right click. We're going to say new job. This is going to be a milling job. We're going to run the stock wizard, and this is going to be based off the BC3X mill. We're going to advance our simulation. We're going to advance through this, skipping the work piece and just going right to the stock. So again, in most cases here, the stock type rectangular is a bounding box, and that's probably going to be the most common stock that you're going to use. But we can use cylindrical stock You will see it ghosted out here if you're using some bar stock or something like that. That's not the most uncommon scenario. Okay, you can adjust which way the stock is going, so I could change whether it's going along X or going along Y. So this way you can adjust where your stock is. I don't know why that is yellow. Okay, so what I'm going to do here is I'm just going to go back to the rectangular stock. I'm going to leave all the default values here and advance to the next step. Now from here, what I'm going to do is I'm going to pick my origin. You can pick a lot of different places for your origin. BobCAD does put this box up here that has all these points that make it really easy to pick common positions like top, middle, or bottom in each of the corners and in the center of the part as well. For us, we're going to go off this back corner here. Now you'll notice at first the z-axis is not aligned with the part, and that has to do with how the part was drawn. So what we're going to do here is we're going to take this section right in here, this section, it has some alignment tools. Okay, so in this section right here. Number one, if you're using a SolidWorks coordinate system, you could go ahead and use a SolidWorks coordinate system. Okay. You know, for us, so if you have a SolidWorks coordinate system, you could pick a SolidWorks coordinate system from the screen. We don't have a SolidWorks coordinate system, so that's not what we're going to use. All right. So what we're going to do instead is we need to use these axes to align our setup to the part. And the easiest way to do this is, let's go to Z. We'll click on this edge here for Z. That has Z pointing down. Okay, we don't want Z pointing down. You can see Z is pointing down. We want Z pointing up. So in order to flip that, we're going to flip our Y here. So we're just going to hit this reverse Y, and then you can see we have our X, Y, and Z pointing in the proper direction. Okay, so we're going to go ahead and check that down. All right, so we have a job set up. Now, the first thing that we might want to do is face off the top of this part, right? So I mean, it's common. Facing is a really common thing. So we're going to go into our machine setup here. We're going to right click. We'll go down to Mill 2-axis. Okay. From Mill 2-axis, we're going to start the Mill 2-axis wizard. Now, the Mill 2-axis wizard, all the questions that we need to answer about the machining process is going to be answered within this wizard. So, you know, anything that has to do with step down, step over, all the toolpath settings are going to be set within the wizard. Okay. When we go to select geometry, that's one of the first steps, you know, select your geometry. So we'll choose select. And what I'm going to do is just go over one of these edges here, and I'm going to right click, and then I'm going to choose loop. Okay. And when I choose loop, it's going to grab that whole area, and then we're going to check that down. All right. So what we've done is we've selected the geometry we want to pay attention to. Okay. Then we're going to go to our machining strategy here, and we're just going to choose facing. We'll choose next. All right. So now we have a facing cycle. If we go back up to the feature here, you can see that it does have a depth. And the reason why it has a depth is it's reading that off the model. All right. I'm going to go pick bottom. And what I want to do is look at this from a front view. And the reason why that's there is there's this little island here that we need to come in and to handle. Okay. So my depth is actually going to be for the top of the part. So I'll just pick the edge, or I could zero it. That's fine. All right. So then from there, I'm going to just jump ahead to my tool size. So this is going to be a 2-inch face mill. I'm going to start in this corner. I'll add a little bump. We'll do 2 direction. We'll say on the workpiece, and then I'll add some radius links here, and that is going to give me my facing routine. The tool is going to come in here, and then it's going to face off the top of the part. I'm good to go. All right, so we got our facing done. Now, what I generally like to do after I've created a toolpath is I'll right-click on that feature, and then I'm going to choose blank. And the reason why I do this is it hides the toolpath, so it makes it quite a bit easier to tell what's going on. If I click on the feature, it will highlight the feature depth. If I click on the geometry, it will highlight the geometry that I'm using. And if I click on the operation, it will show the operation or the toolpath that's there. Okay, so here we've done a facing cycle. Now, Now that we've faced this down, really what we need to do is we have to come in here and machine down this this fun little thing here, right? So what we want to do is machine this level down to the top of this boss here. Now, I don't know. There's a couple of different ways to do that. Let me, we could come in and like profile around it with a larger tool. We could do like a pocket routine as well, where we could come in and address that. So there's a couple of ways that this may come into play, and depending on your experience and workflow, you may decide a variety of different ways in order to get to where you need to be. What I'm personally going to do is I'm going to do an open pocket routine. That's what I just decided right now. So how am I going to set that up? Well, let's go in here under Mill to Axis. Let's do Select Geometry. Now, if I do select geometry, I could come in and grab this tangency, and then I could come in and, well, let's see if that will work by itself. We're going to just grab the boss there. We'll check it down. We're going to go to the pocketing strategy. I'm just going to delete the finish pass. I just want to look at the pocket routine here. We'll set, maybe a 1/2 inch end mill or something like that. All right, we're going to do an advanced pocket. We'll start there, and I'm just going to compute it. And I want to see what happens. Okay, and what happens is I selected this boundary here, but I don't, that's not enough to tell it that it's an open pocket, It's not enough. Now, if I come in here and let's say I select that and I select this outside edge here as well, this is not going to be, and I don't think it is, to be enough to come in there and to do it. What's going to happen here is that, what's going to happen here, let me compute this one again. It did a pocket routine. Actually, what it did is it broke it out into 2 different features, one for the outside edge and one for this edge here. See that? So again, by just picking those 2 edges, it didn't do what I expected. And a lot of times, this is where users start getting really frustrated. They go, oh, I expected it to do something, and it didn't do what I want. Now, when it comes to your selection for open pockets, there's a couple of ways to do it. If the pocket edge, like in yesterday's webinar, touches the edge of the stock, then it will figure it out for you. It will know that it's an open pocket. But in this case, it hasn't really done that, and just picking either the one edge or the other edge isn't giving me what I want. So how am I going to do this? Well, I'm going to create a sketch. I'm going to click on this face here. I'm going to create a sketch. Okay. When I create that sketch, I'm going to do a rectangle with 2 points, and I'm just going to go from there to there, and this one's going to be for construction, and I can check that one down. And then the next one I'm going to do is just convert entities, and that's going to be for this face here. Oh, hold on, let me undo that. I think I had the face already selected. Okay, so let me undo that again. I'm going to do a rectangle from here to here. All right, this is going to be for construction. I'll check it down, and then I'll click on the screen to deselect anything, and then I'll go to convert entities, and I'll click on this face and check it down. All right, now what I want to do is I want to hide this body, so I can go to my feature tree here, and I can just hide this body, and then what I'm going to see is I'm going to see a dotted line, and I'm going to see my boss there. Okay, so I'm going to go ahead and exit my sketch at this point. I'll come back over into here. It's going to indicate that geometry has changed. I'm going to say no, I don't need to update anything. All right, so I have my face cycle. So now I want to come in here and do a pocket. So one of the ways you can do an open pocket is using a sketch. That's one of the ways you can do this. And then, so we'll load in this feature here, and we'll go ahead and select our sketch, right? So we're going to select our sketch, and then we'll come back in here, and we're going to set up our tool. So we'll use our 1/2 inch cutter. We're going to come in and do our open pocketing. We'll set our step over, and we're going to compute. Now, who thinks it's going to work? Go ahead and raise your hand if you think it's going to work. Is it going to do an open pocket? Anybody? All right, so we have some that think it will. Well, yes, of course, it's a loaded question. It is not going to work, okay? And the reason why it's not going to work, if you're a BobCAD user, you know that we use a dotted line to represent an open pocket. In V6, it's a little bit different because SolidWorks will throw away those dotted lines, all right, if you select the entire sketch. How we need to select this is we have to select, I think I can, let me see here. I think I can window pick this part here. No, I got to pick around the edges as such, like this, and I also have to do that with the open boundary. And the reason being is if I just pick the sketch itself, SolidWorks will throw away the construction geometry. All right, so now that we picked this all, we can check this down, we can recompute, and then now we can see we're getting the open pocket toolpath that I expected. All right, so that's a little trick, a little insight to the workflow when dealing with open pockets. Like we saw yesterday, if the surface edge intersects with the stock, the software automatically picks it up, but there are scenarios where you might need to use some sketches. And when using those sketches, when you select the dotted lines, you need to select them individually versus selecting the whole sketch, okay? Now, if we don't like this particular pattern, this is doing, I think it's one-way cutting. We could tell it to do two-way cutting to come in here and to face off the top of that. You do see it starts off the part. It will clear all that material down. There isn't that much material there, so if we want to adjust our step over, we can come in and adjust our step over to kind of maximize the efficiency of the cutter there. All right, so this one here, we did a face cycle, so we can say face. This one here is an open pocket. Open pocket. All right, so now let's get the model back open. So we'll come back to the model here. All right, and we can see what's going on. Again, it's common for me to come in here and blank this out so that way I can look at just what I'm working on. All right, so now we have some more pockets here. So I'm going to focus on this section in here. All right, so what we're going to do is another pocket. So we'll say insert mill to axis. All right. And then we can program from there. You can start from scratch. That's one way to do it. Another way to do it is we can take this open pocket and copy and paste it. When we copy and paste it, we can keep the depth values. All right. We can come in here and reselect some geometry. So, you know, I don't want to pick this face here. That's going to give me the outside edge and inside edge. If we go ahead and pick it, we'll check it down and compute it, and we can see what we get here. It did end up returning the value that we wanted. Let's go ahead and edit this. We're going to go to offset out, or I'm sorry, offset. Yeah, offset out. We're going to do an offset out here. We're going to recompute. Okay, this did end up returning what we wanted, but generally, this is going to be an offset pocket. Generally speaking, you know, you want to be careful when you're trying to select faces as this, you know, especially because it's open here. A lot of times what you're going to want to do is click on the edge and either select a tangency or a loop. Okay, that is usually a better method for our selection here. If we recompute, we can see what we want. And, you know, again, let me remove and reselect. Let's select the face here and compute this. And it looks like we're doing a good job. You know, sometimes you have to be careful, you know, as far as looking through the model because it may be generating toolpath that you don't want it to generate. And if you turn your shading on or off, that will help you see whether the toolpath is going where it needs to go. All right. So even though in this case here, we were able to use this boundary that way, that's not what I would recommend. I do recommend you go to the edge and then you select the tangency or loop. So we'll do a tangency here, we'll check it down, and we'll compute. All right, so that gives us that pocket there. We're going to go ahead and blank that pocket. We're going to copy that pocket, and we're going to paste it. All right, and just doing so, it absorbs the tool or whatever settings that we may have used already. All right, so this one, we're going to come in here. Again, I'm not going to pick this face. I'll pick it. Let me see what it does. It is avoiding our holes there. So, but you do have to be careful of that. Sometimes when you pick faces, you'll pick up other attributes that you may not want. So what we're going to do here is remove and reselect, and I do recommend picking up a tangency or a loop. Usually that is the best method to attack these types of surfaces. So that does the next pocket. Then in here we have some other smaller pockets. So let's blank this out. We'll blank the whole feature out. Let's blank. All right, we're going to copy and paste. So now we've added, we're just kind of making a clone of the feature that we're using here. Okay, this time we're going to come in and select, and in a scenario like this where there's no breakout, that's generally, there's not a pocket inside of a pocket or two edges, just a single edge surface. That's generally when I'll select just the face for the surface. So we're going to select those. From here, we're going to change this. Well, let's go to a spiral pocket. We're going to change it from an offset pocket, and what we're going to do is use spiral for circular pockets, and we'll go ahead and compute that. And in this particular scenario, you can see that no tool path was generated. So sometimes that can be confusing for users. You selected a feature, you have your settings, you don't get any tool path generated. What's happening here is the tool doesn't fit in that area. That is what's happening here. Sometimes it can be the way you've selected your geometry, but in most cases, it's going to be where the tool doesn't fit. All right, so what we need to do is come in here and change our tool size. Now, when we go to change our tool size, I can just type in a value of whatever tool size that I want, and it will search from the database. Or what I can do is go to the tool crib, and then I could grab a tool out of the tool crib. All right, in this example here, I'm just going to type in 1/4 inch, and I'm going to recompute here, and then now you can see the tool path to come in there and to clean up those circular pockets. Okay, all right, so what do we have here? We have a pocket to here, we have a pocket to there, and then we have these pockets there. So that kind of covers those features on that side. Now, a lot of times you want to verify your work, you want to see what's going on. So what you can do is go to any of these operations, right click and choose backplot. And this will show you where the tool starts, what direction it's cutting in, and where it ends. And a lot of times that is extremely important in order to tell what's going on. So you can go through any one of these. If you right click on the feature, you're not going to get the backplot. You have to right click on the operation itself. You can right click, choose backplot, and then this will show you where the tool is and what direction it's cutting in. Okay, so we did a face, we did an open pocket, right? So we got this pocket here. Now, what if we want to simulate what's going on? We want to be able to see what's going on. So what we're going to do besides backplot is we can get into simulation. Now, simulation comes standard. All right, there is machine simulation, should I say. There is machine simulation as an option. 4-axis pro or greater or something that you can add. Generally, I don't recommend it for 3-axis, though some customers have convinced me otherwise. But what we can do is go into a simulation here. We can turn down or turn off the visibility of our toolpath. We can run through and play this. Now, a lot of customers ask me, why does the tool show up red? And you can see right here how the tool's showing up red. Even if you don't have machine simulation, the tool can show up red. The reason why the tool can show up red is the machine models are there. You can see the tool is actually cutting into the table. So there's a couple of ways in which you can avoid this. One way to do it is to delete the STL files for the machine table. It's kind of more of a lazy way to do it. Another way to do this would be to come into your CAM, your current settings. You can go to that machine. You can go to the machine definition. And then what you have is you have these checking groups. So what is in number 1 will be checked in number 2. So what I want to do here is this table. I'm just going to remove the table from my checking group, and then I'll choose OK. All right, so by removing the table from the checking group, then that tool isn't going to show, or it shouldn't show that a collision there because it's no longer checking for that. All right, so we'll run that through. Let's see if it shows up now. Let me step it forward. Let's go next stop. Step, step, step. All right, so you can see I don't have this as a checking group anymore. So as the tool moves along in my simulation, it's not going to show up red anymore. Okay, so if you guys were unaware of that, that is one way in which you can handle that. All right, so here you can see we're facing. We do our couple pockets here, and we're good to go. All right, so if there's any questions about anything I've talked about so far, just go ahead and fire away. Otherwise, we're going to keep going here. So we've done, you know, our facing. We did our pocket down to our boss. We did our pocket inside of a pocket, and then we came in here and cut out these circles here. Now, one of the things that, you know, you should notice, if I go next and I go next, all right, if I start stepping forward here, this one's doing just the plunge move. This is a pretty aggressive cut, so this would need to be a softer material in order to get away with that. Let's go next stop. If we go to this next one here, you know, again, this is taking a pretty aggressive cut right at that point, you know. So unless if you have a really soft material, we're probably going to need to create some additional step downs, all right? So let's see here. Tim had a question, would you have to do that for every job, or is that a permanent setting? It's a permanent setting, Tim. Once you take away that collision checking and you have to save the file that you're working with, it will save that setting. All right, so if we kind of back up here a little bit and we look at this one, our face routine, I think I'm okay with. Our open pocket, I mean, we could come at this a little bit differently. We could use a bigger tool, but I'm actually okay with this. This is fine. This first one here, you know, it's pretty aggressive. We don't have the tool actually ramping in any way. So let's unblank that. We don't have the tool ramping in any way. So, you know, we need to get the tool into the material. If we go to our leads, okay, so when you're looking at, you know, where does the tool need to go in, or how do you change the settings? It's going to be under your leads tab. And then from the leads tab, you can choose either plunge. If you want to plunge, you could choose ramp if you want the tool to ramp, or you could choose spiral. So these are your different options here. In this case, I'm going to just set it to a spiral. You know, I'm going to adjust the radius of the spiral. I'll recompute, and then what we'll see here is that we get a spiral to get the tool down, and that gives us our first level. Now, when we go to the second level here, you know, I want to take, you know, maybe I want to take this in 2 passes, for instance, instead of 1, right? So if we go back up to the top here and we go to parameters, right? So we can go to parameters right here. We can go to this section here, and then under parameters, it's going to give you options for like your side allowance, how much material you would leave on the wall, or your bottom allowance, how much material you would leave on the floor. Okay, what we want to look at is our depth method here. We can go from a single depth to a multi-depth option just by picking this button here. Okay, so we're going to go ahead and do that. So we'll say multi-step. Now there's 2 options here. You have even depths or defined depths. Even depths takes the total depth and then your depth of cut, and then it might make it into multiple. Like if I set this to a 1/4 inch here, then what it will do is it will actually look at the total depth and then create even depths of cut to get all the way down to the bottom. If I set this to a defined depth, then what it will do is take the first depth of cut, and then the second one will be whatever is left over. So if I said, let's say the pocket was, you know, the total depth is 850, but the first one was a 1/4 inch down. I could say 850 minus, you know, a 1/4 inch, and then that gives me this level here. So I could say depth of cut would be, this would be at the top. So I actually want to go a little bit deeper. So let's say I want a 1/4 inch at a shot. It doesn't add up. That might be too much there, but you get the idea where you could force it to go to, let's say, 675 with a defined depth. So what it will do is 675 for the first pass, and then it will do whatever's left over for the second pass. That's how defined depths work. Even depths will take the depth of cut that you gave it, and then it will look at the overall depth that it needs to go and then make it so that you have even depths. If we go ahead and compute this here, we are going to see that we get 2 passes this is one way to do this. I generally wouldn't try to fake the settings or do the math for it. That's generally not what I would do there. What I would do in this example is tell it where I'm going to start cutting, which would be this inside pocket level. Okay, and then I can pick the bottom, how deep it's going to go. All right, so what it does is it adjusts where it start cutting from where it's end cutting. So if I want to take this 1/2 inch in 2 passes, now I can just say multiple steps, 2 passes, recompute. You can see that the preview shows that it's starting at the shoulder. Okay, it shows, like when I'm on this feature here, it shows the top and bottom of that feature. When I click on this feature here, it shows the top and bottom of that feature. And then when I look at my tool path, now I can see I have 2 even depths for that pocket there. Okay, and then the last one here on this this spiral here, I don't need to take it in multiple passes, but what I may want to do is, adjust the step over so I get more than one pass in there. Again, depending on the material. So here we could just drop down our step over and recompute, and then we're going to see an update. And that is how this works. If you make a change to your toolpath, you do need to recompute your toolpath to update for that change. All right, so we have our face, we have our pocket for our boss here, we have our first level pocket with a spiral entry, we have our second level. I didn't add the spiral, so let's go to leads, spiral. All right, we can recompute that. So that gives us our second level with the spiral, and then we have our third level here, which is these circular pockets down at the bottom. Okay, so that looks good. Now let's go to this other side over here. And another thing that you can do with workflow, of course you have speeds and feeds and things like that we'd have to enter in, but you can use these groups. These groups are a great tool. If you go to additional functions and then add group, it just creates a folder in your CAM tree, and then what you can do is you can take all of these items here and you can put them in that folder. All right, so now that they're in that folder, I can blank all of those items at one time, or I can unblank all of those items at one time. I can turn them off for posting, or I can turn them on for posting. So this way you can use that to help organize your CAM tree and make it easier for you to lay out your parts. All right, so let's blank this one out. We've done that section. Now let's look at this section over here. Okay, we're going to come in and do mill 2-axis. We'll select our geometry. All right, for this one here, we can, well, let's see. Let's pick this face. I'm not sure exactly what it's going to do here, so we'll pick this face, check it down. We're going to go to pocketing. Okay, we're going to go to our 1/2 inch end mill. We're going to do an offset style. Let's just compute the defaults. Okay, cool. So, picking this surface here, it did jump over this area. I don't know if it would be any different with the surface edges. Let me check. So I'm going to reselect. Let's go tangency, check it down, and compute. And it did change some start point positions, but other than that, it really wasn't that different. But I generally do pick on the edges versus the faces. Okay, so in this case here, I have this this tool. It's coming in here. It's trying to cut in this section, then it's trying to cut in that section, and then it's coming in here and removing all of this material. Okay, so it looks like it did an okay job with that. That's all right. Of course, we'd want to have it step down. Let's see. Tim did have a question. I'm having problems when going into check or modify settings, and the parameters I have set change to BobCAD default settings. I'm not sure. Is it the BobCAD settings or the SolidWorks part settings? Can you give me a little more details on that, Tim? All right. So in this case, what I have is I have a tool that just barely can fit in this area and this area. Really, what I'd probably do in this case is let's bump this tool size up a little bit. And then let's recompute. And here you can see by bumping it up, what's happening is the tool can't fit inside of this area. And this is really common, you know, where you might use a larger tool and then you want to come back and clean up where the larger tool couldn't fit. So we're going to come back into this feature here. We're going to go to machining strategy and we're going to add another pocket cycle. So we have 2 pocket cycles for this feature, okay? The first one is already set up. The second one, we're going to come back with a smaller tool. We're going to say, you know, maybe a 3/8. We'll come in here and what we're going to do is an advanced pocket, and then we're going to choose rest roughing. And what rest roughing will allow you to do is target where material is left over from the larger cutter. Drop my step over percentage a little bit here, and let's go ahead and compute this. So it will do the first routine, and then it will do the second routine to come in and clean up where the first routine wasn't able to get. Okay, so that's rust roughing for a 2D pocket. Very useful feature. The other thing with rust roughing, you could do this as an adaptive routine. And let's recompute here. So instead of it just, you know, kind of burying the tool in those areas, it will come in and do the tricordial machining to clean up that area. You know, in the first pocket, you could use a larger tool, you know, maybe you know, a less aggressive step down. The second tool could do side milling. You know, and you kind of get into this situation. Do you use traditional offset style paths, or you use the adaptive paths altogether? You know, so it's just something that you're going to have to get familiar with as far as using the adaptive tool paths and taking advantage of them. But I think we're doing all right here. So in this case, we came in, we roughed out the majority of the material, and then we're coming back with a smaller tool to clean up what's left over. If we want to come in here and get into this other pocket, we can say copy. We could say paste. We'll say no. We're going to go ahead and select the, I'm sorry, we're not going to select, let me check this down. Let's blank this guy. Okay. So when we come in here and we select this, we wouldn't select this top edge here. Okay. We wouldn't select these faces in order to do a pocket. If we do that, right, we say, hey, that's the area we want to pocket. Let's select those faces. If we check that down, you can see it actually throws it away. We get no selection if you select the vertical walls. If we come in here and we select this top edge, then that is the depth it's going to read for that pocket. So by selecting that top edge, I can come in here and pocket, and you can see how it's going to pocket from the top of the job, you know, all the way down. If you click on the feature, it will show you. Okay, so in purple, it shows where it's going to start cutting and where it's going to end cutting, because it's reading the depth based off the geometry you selected, right? So instead of selecting the top face, what we're going to do is come down to this bottom face and choose a tangency down there. Check it down, compute. Now you can see it's going down to that surface. If we compute the rest machining, now you can see it will come in there and clean up the corners of that tool. Okay. If we don't want it to start machining like all this air, you can see it's machining that air there. If we don't want it to do that, what we need to do is edit where it's going to start cutting from. So we go pick top, it's going to start cutting from there. Okay. When we want to go bottom, pick bottom, we pick the bottom. Check it down. Okay, so now we've set the 2 levels that it will cut in between. We'll go ahead and compute that, and there you can see we have that tool path being generated. All right, we'll launch simulation. Take a look at what's going on. Let's see here, Tim. Yeah, let's see. I had problems when doing. Yeah, you're going to have to give me a little more information in order for me to answer that question there for you, Tim. Anybody else have any other questions or anything that they want to review here? We're a little past the halfway mark in today's webinar, so feel free to ask any question that you might have as we run through this simulation here. It happens at a time when I haven't changed feature type. This doesn't happen all the time. All right. If you could do your best to like something that is repeatable, that would definitely help. But when, let's see, happens at a time when I haven't changed feature type. This doesn't happen all the time. I don't know. We'll have to look at that together, Tim. I'd be more than willing to spend some time with you to go over some of these features and functions with you. All right, so here we're going to see our simulation as it's working its way through. Using a larger tool to rough things out, a smaller tool to come back in and clean up these areas here. Okay? All right. Very good. So now let's go ahead and look at some tapping, right? So what we've done is we've done everything here. I mean, sure, there's finishing on the profiles we'd still need to do. There's chamfering that we would need to do, but let's take a look at some tapping here. Okay, so let's say we want to tap these holes. We're going to go into Mill Tap Hole. Okay, we'll choose Select Geometry. We're going to select the two holes that we want to work with. We can select the cylindrical tubes there. Those are where you could select the vertical walls. We're going to go ahead and check this down. We're going to choose our thread type that we want to work with. We have a thread library like we talked about yesterday, so we can come in here and choose, a thread type that we may want to work with. On M3, let's say OK. So regardless of, obviously, well, it's a 201, so it's set up for a 1/4-20. But regardless of the geometry that you're working with, when you select those cylindrical faces for a tapping cycle, it's going to find the arc center, and it's also going to pick up the depth for you. Okay, and then the pre-drill and the tap that are going to be called is going to be based from your thread library. So we can run through this. Let's get rid of the chamfer mill here. So we have our drill, our center drill, our drill, and our tap. So we can come through. We'll see our drill is this really small metric number, and then our tap as well is our M3. We can come in and compute that, and this one's going to come in and spot. You may not want to use, this is like a center drill. So you may say, hey, Al, that's a center drill. I don't want to use the center drill. I want to use a spot drill. Hey, no big deal. Come into your feature here where it says center drill. Go to your tool crib, add from tool library, and then you can grab like a 1/8, 3/8, or whatever, any of the standard spot drills that are already set up for you. Okay? You say OK. So now we have a spot instead of it being a center drill. Okay, all right, so here we have our tap. So we'll come in here, tap our holes, and then, drill our holes, and then we'll tap our holes. All right, very good. So that's kind of what I wanted to cover here today. What else do you guys have? What are we thinking, Mark, Roger, Ted, Todd? What kind of questions do you guys have? Is there anything you'd like to see covered? Eric, Gary? Let's see here. Let's see what we got. Who has a microphone? Anybody have a microphone? No? Okay, no big deal. All right, well, I know Tim had a question earlier on too, as far as, let's say this is all within one setup. So we're machine setup 1. Let's say that we needed to turn the part up on its side and do some machining on this, right? So we're going to come in here. We're going to say insert an additional setup. So we'll do insert setup. We're going to go ahead and edit our setup location. So we'll click on origin and choose where we want our origin to be. We'll check this down. So now we know we're in our second setup here. And then from here, we can do any of our routines. So let's say we'll do 2-axis. We're going to say chamfer. Call our chamfer mill up here. This looks good. Let's select our geometry. So we're going to go ahead and let's pick this face. From here, we can deal with some of our lead ins and lead outs and that kind of stuff. Chamfering is a composite feature. In other words, it oftentimes is included with other 2-axis routines. So, your feature depth here really doesn't matter when you're working with a chamfer. In the chamfer dialog, it has a specific depth that you can pick up on. So we can set what this is. We'll go ahead and compute this. Let's see what we get. Let me see. So we're seeing nothing on this particular one here. This was from selecting that face. So what I'm going to do is remove that face, reselect, and I'm going to select a loop going that way. All right, let's recompute. Okay, so I can see the toolpath now. Let me go to, that one doesn't show through. There you go. This open box, this one down here at the bottom, the wireframe will allow you to be able to see through the model. And that is a very important feature so you can see if the tool is going on the wrong side or what have you. So with this chamfer routine here, if we click on default chain start point, you can see the arrow. The arrow is where it would start cutting, and it also sets the direction of the cut. So what we're going to do here is just right click on default chain start. We'll hit reverse direction. We'll recompute, and then you can see we have the break edge on this outside, right? Okay, so now what we can do is get into simulation. Let's see, Todd has a question. When you do a second setup, is it necessary to recompute the stock geometry because of the new orientation? No. So I did program the first setup, Todd. Now I'm in the second setup, right? So here I can go through and let me just go next stop, next stop, next stop, next stop, right? So I'm just nexting through what's going on, all right? So I can see what's happening. And then from here, next stop, next stop, next stop, next stop. All right, so now we're in the next setup right here. We can step through this. And you can see, I obviously need to adjust some depths, but you can see even though I'm in a second setup, I didn't have to create extra stock, and it knows the condition of the stock as I go. It just keeps programming the part just like you would. Okay, Todd? So, you know, when you're going through this next stop, I turn a lot of these options off because I find them distracting. I like a cleaner interface. But if we come in here and we go over move list, the move list will actually have all your operations here. So if I restart from the beginning, let's say I wanted to get down to the chamfer feature, instead of guessing as I next through what's going on, I can actually just click on this one here. It will fast forward the simulation, so that way I can start exactly where I want. All right, so let's go ahead and check this down. Let me look at my depth here because I really didn't get the cut that I was expecting. It may just be because it's light and the simulation didn't see it. So let's make this a little more aggressive and recompute. Let's get back in the simulation, see what other questions we have. Al, I was thinking of the type of part you were using in the other webinar, the valve cover. It would be different. I realize this is a 2D webinar. If you copy and paste your settings, whether it's 2D or 3D, it shouldn't matter whether it's 2D or 3D. So again, the idea is I would like to go through the valve cover webinar, the 3D one in BobCAM as well. So we'll see how that goes. But it shouldn't make a difference whether you're in 2D or 3D as far as saving your toolpath settings. All right, let's jump all the way down here to the last one. Here we can see what's going on. We're going to just step through. All right, this one's showing up red, but again, you know, we did our programming in our first setup, and we're able to see it in the second setup. Now, there are some red X's here showing us that there's some kind of collision or issue happening. I'm not sure why it's showing up red on this. Actually, I do know why. And there are pop-ups and warnings that will tell you what's going on. Let me see here. Some statistics, report, collision between workpiece and tool. Okay. So I have some collisions between the workpiece and tool. The reason why I have those collisions is because I've machined a chamfer, but I didn't model the chamfer. So it's making contact with the part, and it's telling me that the tool is making contact with the part. Actually, if you click on the collision location, it'll actually tell you where it is. It will tell you the operation. So these are definitely useful tools when you're trying to prove out your programs and really see what's going on. All right, so let's go ahead and close our move list down here. And what I'll do is I'll open up to any questions that you guys may have. If you guys don't have any questions, we'll shut it down for today and look forward to seeing you guys tomorrow. We'll see what you guys got. You know, as always with BobCAM, you can expect fewer steps, better cuts, and more profit. I appreciate everybody spending some time with me here today. Unless there's any additional questions, I look forward to seeing you guys in day 3 of the BobCAM for SolidWorks 2D kickoff. Day 1, we covered a lot of the basics of the software, a lot of the different settings and locations of where things are within the CAM tree. Day 2, we just went through a part from start to finish. Day 3, we'll see how that goes. Again, I appreciate everybody spending some time with me here today, and I look forward to seeing you in the next one. Thank you so much.